So for the real-time map, I described the sort of left side and the button. What I'd like you to do is click on that map. So either click on the state of Utah or click through to the, go to the map button, and you should get a page that looks something like what you see on the left. You'll see a few navigation tools. You'll see a clock on the upper left-hand corner, and you see some buttons over here on the right-hand side. The one we're going to explore first is the one that looks like a map icon. So go ahead and click that, and I'm going to walk through what the different layers mean. So the different layers of the map are two speed layers. One that we call free flow speed. It doesn't have the word offset after it, and the one we have that has the word offset. And so Terry described to you in the data discussion that here provides offsets. So we let you see the map at the TMC level. It's really the only place that we visualize the TMCs. And so if you cared to see the data over the TMC link and the aggregation of that, you could see it that way. By default, we have the offset map on because that's the most detailed data that you could get at any point. And so that's kind of the default layer. The second radial button is called anomalies. That we'll walk through that in a bit, but it's the comparing now to history to see where things are better or worse than normal. Quality, which is showing you an aggregation of the score as a color map. Roadway network, which is using here's functional classifications. Distance markers you can turn on or off to see the mile markers on the map along the map. We turn them off by default because they're fairly busy, but you can turn them on. And then bottlenecks are calculated in real time to display. In the lower right-hand corner, if you click these little arrows, it will pop up in a legend. And you'll see two legends. There's one that's a % of free flow and one that says a % of arterial free flow. So we're using slightly different scales for the two because if we use the same scale, you would get too much. It doesn't really work for arterials, and so we changed the threshold to be slightly more, more free flow is contained in the green in the arterial case than there is in the freeway case. We do this % of free flow because it normalizes the data out between the different types of network. If we just pick speed, you would just see red all the time on the arterials. We do have a speed layer. If you did want that to be turned on, we could do that, but by default we don't have it on here. So the % of free flow speed, as I described, the width offset is what Terry called the sub-TMC or offset feature. So it's just pulling along that link where the speeds are actually different. And then the free flow speed is the TMPC based. Go ahead and select the anomalies layer. And what that will do will bring up a slightly differently colored map that ranges from this middle color of milky white, yellow, to green up here at the positive end and red and this orangey color at the bottom. So what it defaults to is it's comparing the current 5-minute traffic speed that's being provided to the average traffic speed at this 5-minute time of day. So it knows both for weekdays and weekends what the different patterns are. And so if you're looking at this on a Saturday, it would use Saturday's pattern. And what it's showing you is compared to the average condition, how different is it now versus normal.
So is it a rolling 4-week average?
Yeah, so we calculate this every month. So come June 1st, and it will recalculate the long-term trends, and it will use the prior month's data for it. We have experimented using longer data sets in our current database structure. That proves to be computationally expensive to do, and it takes too long to process. We are experimenting with some serverless aggregation processing based upon some of the interest that UDOT has for some other data sets, and we're able to process data much faster. So we may change the long-term trends over to something that's longer, but at least for the time being, it uses the prior month.
So it's averaging the past, some kind of a historical average.
Correct.
And these are in 5-minute segments, you said?
Yes, that's correct.
And so based on the current condition versus this average, if it's greater, and it's all based on speed differential, okay?
Correct. So it's the percentage difference between the
Basically,
average.
do we have that on all the freeway and the arterial routes, or just the freeway?
Yeah, so one thing I didn't talk about yet, the closer you get on the map, the more roads you see. So, so let me pull up. So you can see that now I'm starting to see more roadways as I zoom in. And the closer you get, the more roadways you will see. So now I'm to the 13th zoom level, and so I'm seeing more roadway covers. So the average doesn't work out super well on arterials. So we give you percentiles. So in the calculation we're doing from the 5th to the 95th. And so I can compare to, say, the 10th percentile, and that will give me, compared to terrible in the past, how are we doing today. So in this case, it looks like we still have a fair amount of arterial redness. And Jamie, you had a question?
Yeah, so the averages and the percentiles, are those calculated using the speeds you reported at the time or going back to the raw data?
So it's using the aggregate 5-minute speed that we're recorded now and comparing to the 5 minutes pattern in the past. So I clicked on this individual link. That's not too different. Let's do this one here. Yeah. So this one sort of shows. Let me pick this one up here. So it looks like you're doing some construction. So this is a nice example. So in my legend, so this is greater than 25% below. So in the range, I'll take off the average. So this is the range of normal conditions. So I can uncheck these charts. I can pull up today's speed and compare that to the range, and you can see the blue line is below the normal range. So,
There's 2 lines.
pardon?
I mean, like, there's 2 monthly ranges. Is that a high and a low?
That's the min and the max. And the coloring is the range between it. So, so if I take this off and I show this, so in the morning you've got a larger range, right? So the range goes from 26 miles an hour to 67. But at the current speed, there's not much of a range. And I'm zooming into the chart to see closer. So your normal average for this location is 69 miles an hour, but today you're at 50. So you can tell, compared to normal conditions, this is abnormal.
Did you zoom in on the chart?
You just drag the line, you drag your mouse across the chart and you can zoom into the section.
So in a month, the slower speeds are going to be the normal now then?
It would incorporate this, but it's the aggregate over the, so all of the weekdays get included into the weekday processing, all of the weekends get included in the weekday processing. So if you did have, so say you had a construction project and that becomes the normal, we're incorporating that and it would use that to compare to normal because that's the aggregate that we're doing. If we were doing something slightly longer, then you would start to wash some of that out, which I'd like to get to over time if we can get the processing to behave.
Can you show them how to do zooming in?
Oh, sure. So, so you can so to zoom in, you just drag your mouse across and highlight the area that you want, and then you let go and it zooms you in the area. You can do it again and get closer. If you don't like that, you can sort of start again. So that gets me to the process. You'll see that the time for 9:55 means 9:55 to 9:59:59, and so we're comparing the timestamp in iPeMS always represents the beginning of the period. And so we wait until we get all of the data for that 5-minute period. We aggregate that, compare it to the anomalies, and that's what you see in the chart. The rolling current speed, we take every minute, we aggregate that up into the 5-minute period, but the anomaly that you're comparing against is slightly older because we don't have that data yet to process against.
Can you show them again how to activate and deactivate different lines?
To pick different.
Show like monthly average or take it.
Oh, okay. So these bars at the bottom you can check and uncheck. So if you want to just see the day speed, you can filter off everything else, and it just pulls up what it has for today, and so the line represents just the current day up to now. The average is the average for the prior month, and then the range gives you the range for the month. And so you can take these on and off to, and then if I hover over the monthly range, I get to see this sort of coloring around it as you see sort of see fit.
They might be interested in knowing the confidence score value.
Oh, okay. Yeah, so I'll get into that in the next slides. So that's the anomalies piece. So I'd like to go through the map layers sort of first, and then we'll get into what the data in the balloon means.
Can I just ask you a quick
Sure.
question? This one has opposite sides showing on that table. Yours didn't have it on there, it had upstream and downstream. Is the opposite side, see?
Yes, there should be an opposite side that you can pick in your selection.
No, you mean like eastbound or westbound?
Whatever the opposite side of the road is. So if you pick northbound and you click opposite side, it should shift you to the southbound side.
You need to zoom in close enough on that line to see which direction you're going.
Yes, correct. But it will also tells you in the top. So I can see this is 215.
Actually, quick question on the directions there. That one says I-15 south because ultimately that's going to kind of go around the corner and become southbound. And those convention carries across the top. How are you dealing with I-15 since it kind of goes a whole,
15 or 215?
215, sorry, since it kind of goes,
So the directions that we use are the directions that here has, and so I guess there's two direction elements. When we get into the details about an individual link, we have both the direction on the sign, which here collects in their LiDAR reports and then provides that into the map data. And then we have the cardinal direction of like which way is the road actually going. And so the link will tell you that. We just give you the direction on the sign on the label here.
You just said you collect LiDAR?
All of the stuff that Terry didn't talk about is what goes into building the map. And so they run vehicles around and do lots of work on the map attributes themselves. And they run vehicles to do LiDAR to capture all of the things about the roadway. And then we take the map data that they provide to us and incorporate it into iPeMS so that we have the speed limits, we have the attributes of the roadway, we have the geometries of the roadway, and we can make it precise in here from like a GIS perspective for you to use.
Here has a Subaru Forester here in the valley that I've seen several times. It's got the system driving. That's what they're doing, just driving around.
In here, we're getting some extracted attributes out of that mapping process that's producing, for this link, these are all the attributes that are associated with it. And then we're using that to display inside of the tool those particular attributes. So that we're fairly far removed from that process, but we're the beneficiaries, and you are the beneficiaries of the downstream recipient part of the process. And so having selected here as part of this team, you kind of get that as the kind of additional benefit.
So this is 100% probe-based, and there's no interface with UDOT's detectors at all in terms of calculating the measurements, right?
It's tied into the UDOT.
So
It is.
we've integrated them, but we don't, if there are any probes, we really don't use the sensor data.
So what we're going through today is the third-party data, then a volume-based profile that's produced off the iPeMS data to do the calculations of vehicle hours of delay. We also run the freeway detector-based PEMS that we're going to go through in tomorrow's class that's actually processing the 3,000 detectors in from Utah and puts it into a separate system.
There's no cross.
We're not currently cross-pollinating the measured traffic volumes, in part because HERE's network covers everywhere. And so we needed, in order for you to be able to calculate the delay-based measures, you need to have a volume assigned to all the links. And so the easiest way to do that, or a step to do that, is to do the iPeMS model. It gets you part way, and we've had some conversations with HERE and some conversations with UDOT about how could we, when the next volume update happens, do you want to try to pull in some of the measured data? Do you want to try to do some more sophisticated modeling? What do you want to do in the areas that you have detection? Where do you want to do in the areas you don't? And how does that work? And so that's a bit of a technical process. And so this gets you, in this particular tool, gets you partway there, and then you have access to the other tool to give you the real measured volume-based data to compare against to help you as you're analyzing. So that's a great question to kind of understand the differences between.
Seeing volumes, when we get to that page, those are not from the sensor locations. Those are estimated from AADT and iPeMS data. So then we'll go tomorrow over the actual sensors that are bringing them in. And those will be actual volumes.
Just, I guess, while we're here, since a bottleneck showed up, it's calculating the bottlenecks in real time. We'll go through that in the afternoon. But it's calculating those where it finds them, and we have specific conditions that it uses to do that. But it's doing the calculation on the different, and you can see them on the different map layers. So there's some other layers. So this is the road network. This is here's representation of the functional classifications. This is not UDOT's functional classification IDs. This is essentially interstates is one. Things that connect to interstates is blue. Arterial, like bigger arterial roadways are the 3. Slightly smaller arterials are 4, and then all the local streets are 5. And ramps are colored with a different class. So it's just another attribute that's in the map that we provide in that's accessible. And then as you get closer into the map, you'll see more roads appear. So you see more roads appear. So now I'm down deep. These are the local roads. This is where you're getting your DLR coverage that Terry described. So all those links are available, and you can see, but you don't see them at the out part because the map would be too busy. But know that they're sort of deep in the process.
As you drill down, you're getting into lower functional classes.
You can see them. So from this level here, right, I can't tell that these roads are clickable because I'm sort of out. I'm out a little far. But if you want to analyze something, all of the road network is there. If you want to analyze something that's on a local street, you can do that. We just don't make it visible because the map would be busy for you, and so we hide that until you get closer into the map itself. So I'll zoom out a little bit just to kind of show there's a quality layer just so you understand what this means. We're taking in currently scores that are greater than 0.85, and we're calling that high quality. This is some of a legacy number that we picked randomly from the past. Through some discussion with here, they recommend to do the 0.75 as the scoring. So essentially what this is doing today is the darker the blue, the more samples you're getting, the higher the scores are. The lighter the color, the less samples you're getting, and the lower the scores are. What we decided to do, and it will probably be in the next release or maybe 2, we are going to use the native score and then do a coloring based upon that. So here provides a range from they technically have 0.5, but 0.7 to 1, where we're going to color it on a scale to show you that instead, and then you can interpret that as you want, as opposed to us coming up with some artificial version for that. But it's just a way to kind of see, how much data am I getting currently for this particular section. You can see these, the freeway segments are all very blue, dark blue, and then you've got, some sections of North Temple that have more traffic, and so they're getting slightly darker colors, and then other ones that have less traffic, and so you're getting lighter colors that are below the threshold.
Is that a measure of the quality of data that you're getting from those roads? It's a measure of total traffic on those roads?
It's essentially a measure of the total traffic in a way. It's not telling you that the value is good or bad. It's telling you that there's less probe vehicle measurements measured data in that data set than there is in other places. So along the freeway where you've got a lot of cars, you get a lot of samples, the numbers are much higher. On the arterials where you get some samples and you get the path data over certain pieces, more of the data in the value there's some modeling weight to the historic pattern, and then some real-time weight. And that here's got a black box that's producing that value that they've determined is the correct speed for that segment. And we get a score that says here's the confidence score, not a statistical confidence, but a confidence score of range of numbers that tell you essentially how much data is there. They don't tell you there were 8 vehicles that were measured in this spot because that gets a bit deep into the privacy realms. So they mask that in terms of a confidence score.
So that's what the confidence score is what? Is it 0.7 you're?
Yeah, so 0.7 is historical only. So it's the pattern that here's processed. And if you see points,
Understand the percent of high quality.
yeah, so this is confusing, which is why we're changing it to the 0.7. But for now, this is just for the 5-minute sample, what percentage of those 5-minute readings, what percentage of the 5 1-minute readings we got are greater than 0.85. And so it's an artificially weird numbering system that we think is confusing, and so we're changing it. And then, so I'm going to take this back to here, and then you can turn on distance markers. So we have we get the mileposts from the here map. The farther out you are, the less mileposts you see. The closer you get in, you can see more of them. We get down to 1/10 of a mile. So each of these links, we have the mileposts attached to them, and then we enable little green boxes that show the...
That's just on the interstate, right?
It is on more roads than you would think. So it's wherever here's decided to put them. But they do show up. I think if I zoom out too far, it won't show up. But yes, that's correct. It's mostly interstate. But there are some that show up, I think, over here down. So you get some over here near Park City. So it's the measured distance along. So you get a fair amount of them, actually. And they became busy enough that we decided to hide them by default, and then you can turn them on if you want.
So you said that was your measured distance along the route?
It's also a LiDAR attribute.
So it would roughly match the mile posting, but
It may not be
precise.
perfect.
It'll match the posting, but not necessarily the true linear referencing
Correct.
system look.
Yeah, so be a little careful in terms of, does it actually line up with the, we're processing it off the map attribute. We're taking that as the value that is the best sort of way to represent that on this particular network. It theoretically is where the sign is. It may not be perfect, but I think you'll find that they're pretty close.
It's pulled up from the LiDAR data.
Yes.
Correct.
Correct. So assuming that the LiDAR processing worked, it should be at the same place.
You might have mentioned this earlier, but the construction zone symbols and the incident symbols, that's not pulling from UDOT's.
It is so here, Terry showed you the picture of the people at the desks doing the traffic incidents. So it's those folks watching your information and any other information they can gather, putting into their system what they think is valuable to enter, and then we receive a feed of that information from here. Here's been working with Utah to get access to the commuter link or center TransLink feed, TransCore's feed that provides out the incident data that you produce that they then will add to the incidents here. But currently the incidents are a curated version of what here's calculated is important to include in the tool. So there's a little widget here in the map. There's a little gear that you can use to filter out the bottlenecks. So the bottlenecks are calculated every time when it gets to be a lot of them, it kind of starts to hide things, and maybe you want to just see more severe bottlenecks. So we're calculating the delay per vehicle, not the vehicle hours of delay or anything like that, but delay per vehicle. And the queue length in terms of miles, and you can put filters in there to filter out bottlenecks that are shorter or have less impact. So if you want to your map to see a filtered list of bottlenecks in real time as an operational tool, you could use this to do that. So for example, this bottleneck here is 0.2 minutes per vehicle. Say I don't really want to see that. Let me make that at least a minute. That goes away. So I filtered it off of my list. I can go back in here and delete that, and it comes back. So it just gives you another tool to kind of control what's on the map itself. So we spent some time in the pop-up. So I've done a little bit. If you're following along in your books, we're on page 31. So I opened up one of my sections. So you can click on wherever you'd like to analyze on the map. I picked this red link down here on 215 that I thought might be interesting to show. So we went through a little bit about what's in the chart, but and Grant tried to get me to go ahead, but I wanted to wait till I was here. So there's a bunch of stuff here at the top of the chart. So we went through this lower section and talked a bit about the data itself. Up at the top is the current speed. So at the very top, so it says this section is now 39 miles an hour. It has the speed limit that we're getting from the map data, the free flow speed, which we get from here. So here calculates the free flow speed and sends it to us in the feed, and we use that as the free flow speed value. The historical average is what we calculated in the long-term trends for the prior month. So at this 5-minute period, it happens to match what the free flow speed is. That's pretty good. And then the percent of free flow is the current speed versus the free flow speed. So you're getting a red color here because we're less than 60% of the free flow speed. So this at 56% of the free flow speed, we're getting this red color for the freeway segment. In the next line is from milepost to milepost. This is the milepost data turned into what this link represents. We might be a little too precise with 3 decimal places. We might round them to 2 later, but it's these very, very tiny links, and so we're telling you this section represents these mileposts. The data source is just the TMC ID of that link. So that's the have people seen TMC IDs before? It would help to describe what that is.
Yes.
Okay. So there are a series of numbers after the TMC. The first 3 numbers represents what's called a table. So here divides the country and the world up into tables. And so UDOT's table is called Table 116. So all of your TMC IDs will start with 116. Then there's a plus or a minus, or an N or a P, which represents the direction of the roadway. It doesn't necessarily relate to north and south or east and west. It kind of depends on the roadway and its direction, particularly on this link that we had before, where the 215 goes around in a loop. It gets a little quirky. And then the last set of digits is just a unique identifier for that link itself. Here changes TMCs sometimes, they change link IDs sometimes, and we map them together. So we go through a process that updates the map network. So when here starts publishing a new map, the TMCs can change in length. They can change in, the link IDs can change. They could change IDs for that particular section and say that, so here has had some longer TMC links in Utah, and they've shortened what was an original ID to something that's split into multiple TMCs. And so we take the process and we map those all together And what you see on the outside is whatever data happens to be on this link. The current map name is up here in the box, and then in the links themselves, we show you what it used to be, and help you describe that. So what you're seeing here, this balloon stays open with whatever data I opened it up to, so it's not updating in real time, so it doesn't change on me. What we saw here when it jumped down to red was we got speeds that dropped fairly dramatically, where something might have been going on at this spot. So from here, I can navigate like I just showed you before. This is showing you the difference in speed versus history. These little bars over here on the right-hand side let you print the chart or export it as an image if you wanted to spit that out. These little bars carry around to different elements of the other reports, and so you can, when you see them, you can push out the image to save it. And then you get navigations to up and downstream, and into opposite. You should get an opposite side link. If you don't see the opposite side, you can let me know, and we can figure out why. So I can go, to the opposite side of this link and see what's going on the other side of the road, and come back and see what's happening here. So this looks like we had a dip for a little bit, and it came back up. We're processing, if you see here on the timestamp, so this is the latest 1 minute reading that we received in. We're rolling that up over the 5 minutes. So if you have a sort of short burst of problems and it comes back, you'll get different colors over time, which is why this doesn't show the bigger drop, because it was a small period that it had and then came back. And then you can see the map changing colors as it updates. So now we're on 1026, and it continues to update every minute as it goes through. And the other element that I wanted to show is the confidence score. So remember I described that there's a range of confidence scores that runs from 0.7 to 1. So this is a confidence score of 0.965, and that means that there's a fair amount of probe data that's being collected that here is processing through their algorithm to tell you that there's a fairly dense collection of real-time data in this section. So that's a fairly high score, and so you know from that you've got a good sampling of probe data, and you can use that in your studies.
And the kind of lower end cutoff that's 0.75.
The lower cutoff is if there's no model at all, it's 0.5. So speed limit is 0.5. 0.7 is there's a historical, so on a new roadway, for example, where they didn't have any data and they enabled it, or a low volume road, could be 0.5. 0.7 would be a low volume road that didn't have a lot, or at 2 a.m. kind of time period. And then it just ranges depending on sort of what road it is and where you are and what time of day it is. So now we're going to go to page, and I described that a little bit, I guess, in the terms of the confidence scores in page 33. So I'm going to click on a different button, that little exclamation point. So this gets me to the incident layer. We have different types of categorizations. We're processing data in from the here categories into some normalized categories that we have. And you can turn these, so we're categorizing them into the categories that you see here. If I want to get rid of a category that I don't want to see, I can just click this, click the icon, and it will hide the category. So I can hide all of these ones I don't want to see. I can bring back the ones that I do for whatever characteristic they are. So these, it tells you when it last updated the incident, when the last incident came in, and then you can hide them all together with this green button that takes them all away if you want. Sometimes we have multiple incident sources for a map, and so there are occasions where we pull in like official crash record data or social data or data like this. And so for other clients, you might have multiple buttons, but for this, we just have the one. Then you can select a location and see information about it. So clicking on one of the icons, so you're doing some resurfacing work. It tells when the start time of this, so this is like kind of the first scene date that we got, and then the end time is for long-term items. It's here keeps extending it, and so it could go longer. And then the categorization that we have, who's sending it to us, what severity that they've graded it, and then the details about it. We're getting slightly more information than we're displaying here. We're looking at how we want to sort of display that over time. I was waiting till the UDOT data came in to analyze that all at once to figure out whether we want to expose more or less in this box.